Hey, it's Professor Gould. We're going to start our second foundational lecture. This one is on the metric system and scientific notation. And if that sends a little shiver up your spine, you know what? I am right there with you, but don't worry, I got you. We are going to break this down and make it make sense. So don't worry, you're going to be a pro. All right. I'm going to start this a little differently than people normally teach the metric system. I'm going to start with a question, and then we're going to work through some data to answer this question and learn how to use the metric system as we're doing it. Hopefully this is going to work. So the question is fluoride in drinking water bad for you? We could do a really quick Google of this, and we would find both that the answer from reliable sources is no, and that this is a really popular conspiracy theory. It's been running around since cities started adding fluoride to drinking water back in the 40s and 50s. And they did that because fluoride is important for bone and tooth development. And when they started doing that, people got fewer cavities. So it's actually a public health good. But let's look at some data and figure out for ourselves whether this is actually true. All right, so fluoride, what is it? It is an ionized form of fluorine. That's the element. It has one extra electron. Fluorine is in column 7 on the periodic table, so it has 7 electrons in its outer shell. It's stable when it takes one extra electron and that outer shell is full. So fluoride is the way we often see fluorine in the environment. It is really important in small doses, and it is added to tap water at 0.5 to 1 parts per million. In high doses, fluoride is toxic, and the data I'm going to show you comes from this paper here. Fluoride can cause gastrointestinal distress, some pretty serious things, at 0.2 to 0.3 milligrams per kilogram of body weight. And if you're thinking, that is not helpful, I don't know what I weigh in kilograms. Neither do I. So we're going to work through this. Don't worry, I got you. We know that fluoride can cause excess bone buildup if you get too much of it, and it can cause your ligaments to turn to bone, which is not good. If you get more than 4 milligrams in a liter of water. Now this is, well, actually, we don't know until we define these whether that's this. What is it? I don't know. Let's find out. Okay. It can cause kidney disease at doses of more than 8 parts per million. That's way more than you get in tap water. And it's fatal if you get up 5 to 10 grams in your body, and that depends on how big your body is. Okay, so this is a lot of numbers and a lot of different units. So we're going to break this down and we're going to look at each one individually and see how these units relate to each other and what all of this stuff means. All right, so you've heard this before. You know this. You've been given a table of, information, which just, if you're like me, makes your eyes go cross-eyed. By the way, you do not have to memorize these conversion factors or anything. Okay, all of this is going to be given to you. All right. The metric system uses standard units and then modifies those with prefixes for units that are smaller or larger than the standard. So the English system, we have ounces, pints, and gallons, getting progressively larger. In the metric system, milliliters, liters, and kiloliters, those are all ways of measuring volume. The standard units in the metric system, we use gram for mass or weight, we use liter for volume, we use meter for distance, Celsius for temperature, and seconds for time. You will see some things that say Kelvin for temperature, but no one uses the Kelvin. It's not biologically useful. Kelvin. We use Celsius. Now, notice that some of these are lowercase letters and some of these are uppercase letters. Those are important. You cannot willy-nilly switch lowercase and uppercase letters. For things like this, whether the letter is uppercase or lowercase is meaningful. All right, now the prefixes. We're going to add these to the front of the standard unit to get a different unit. Centi means 1/100th. If you think of a meter as $1, A centimeter is 1/100th of that, and that would be a penny. Okay. Milli means 1/1000th, or 1 times 10 to the third, to the negative third. And then micro is 1 times 10 to the sixth. It's 1/1,000,000th. So it's a really, really tiny, tiny, tiny thing, whether it's grams, liters, or meters. We note micro with this little Greek letter. If you can't find the symbols on your computer, or you're working on your phone or something that doesn't have the symbols, you can write out micro, or you can just use a letter U. Okay, that'll work. All right, now those are all smaller than the standard unit. To indicate something bigger than the standard unit, we use kilo, which means 1,000. Mega, which is 1,000,000 or 10 to the sixth, and then giga, which is 1,000,000,000 or 10 to the ninth. Okay, so if we're talking about money and a dollar is the standard unit, then $1,000,000 is a megadollar. Okay, a $1 billion is a gigadollar. Jeff Bezos has like 200 gigadollars. Too much. When you put the prefix with the unit, you get a new unit that's either bigger or smaller than the standard unit. So 1 milligram, or mg, is 0.001 grams, or 1/1000th of a gram. A kilometer, or kilometer, either's fine, is 1,000 meters. Okay, and you just put the K in front of the M for the meter. All right, don't worry, you will get used to it very quickly. It's the conversions that are going to make you a little crazy. All right, so when we need to convert metric units from one to another, say from milligram to gram, or meters to kilometers, we're going to use these conversion factors, okay? And that's just these things, okay? So milli is 1/1000. So there are 1,000 milliliters in 1 liter. Okay, because each milliliter is 1/1000th of a liter, right? You're going to be given a conversion chart. Don't stress out. All right, so if we want to know how many milliliters are in a 2-liter bottle, we're going to start with the information we're given, 2 liters, okay? And then we're going to use a conversion factor, which is just a fraction, okay? An equivalence. So the thing that we want, the unit that we want our answer in, is going to go on the top of our conversion factor. We're going to start out with our given value. Always include the units. Never leave the units off a number. Then we're going to have the equivalence. Whatever we want our answer in, how many milliliters. That's what we want our answer in, milliliters. We're going to put that on the top. And then on the bottom of that, we're going to put liters, so that when we do a little bit of algebra, those liters cancel out. Ah, clever, right? So then we're left with 2 times 1,000 milliliters is 2,000 milliliters. So the liters canceled out. We're left with milliliters as the only unit left. Okay? Boom. Easy peasy. All right? Yes, there are going to be a couple that are a little more complicated, but don't worry. It all comes down to this. Okay? Make sure whatever unit you want your answer in, make sure that's on the top of one of your conversions. Okay, and make sure your other units cancel out. Boom, you're done. All right, so let's go back to this and let's look at this rate at which fluoride is added to tap water at 0.5 to 1 parts per million. That means parts per million means milligrams per liter. Please accept that one. The math is complicated, actually. And so 0.5 parts per million is 0.5 milligrams per liter. Okay. All right. If you're like me, you're like, that's great. I have no idea how much that is. How much am I drinking when I'm drinking water? Like, I don't know how much liter is. The only thing I know is that Germans drink a liter of beer at lunch. Like they don't serve beer in pints, they serve it in liters, which is so much beer. Okay. Anyway, so I didn't have a conversion of liters to ounces. So I went with liters to gallons. So 1 gallon is 3.79 liters. So we set it up. We want to know what is a liter in some other unit. So we're going to put gallons on top. That's going to be our answer. We have 1 liter. 1 gallon is 3.79 liters. So the liters cancel out. We divide 1 by 3.79, we get 0.26 gallons. Okay, so that means that a liter is equal to about a quarter of a gallon. It's a little more than a quarter gallon. Okay, so that's a quart. That's what a quart means. It's a quarter of a gallon. You didn't know that, did you? Once you know it, you're like, oh, that's cool. Okay. All right, so I carry around a 24-ounce water bottle. How many liters is that? Well, 1 fluid ounce is 29.6 milliliters. So we start off with our 24 fluid ounces, and then we want to make sure that we're going to cancel out these ounces, and we want our final unit, liters, to be on top. Okay, so let's get the ounces on the bottom so they cancel out. So 29.6 milliliters is 1 ounce. 1,000 milliliters is 1 liter. So we cancel out ounces, we cancel out milliliters, we multiply 24 by 29.6, and then we divide by 1,000, and we get about 0.7 liters. Okay, so my 24-ounce water bottle is about 3/4 of a liter. Good? All right. So there we go. Hopefully that makes sense. So if I'm drinking my 24-ounce water bottle, I'm getting not even a liter, which means I'm getting, wait, how much? Like maybe 1 milligram of fluoride? That's not, well, wait, hang on. 0.2 to 0.3 causes a gastrointestinal distress, except it's not just this amount, it's this amount per kilogram of body weight. All right, so, oh, I had one more thing I was going to work out before we did that. So if you drink 8 glasses of water a day, assuming that those glasses are 8 ounces each, how much fluoride are you getting? All right, well, first of all, you don't need to drink 8 ounces of glass. 8 ounces of glass. Don't drink glass. That's bad. You also don't need to drink 8 glasses of water. That's what I was trying to say. This is a complete myth. It was made up like 40 years ago and just keeps getting repeated. If you're thirsty, drink water. If you're not thirsty, you don't need to drink water. If you like drinking water, go ahead and drink water. Okay? Trust your kidneys. Okay? They're going to keep your water balanced. All right. So 1 gallon of water, 8 glasses of water, 8 ounces each, that's a gallon. All right, so we got 1 gallon of water. We got 1 milligram, I'm going to go with the higher number, okay, of fluoride per liter of water. But we need to know what that is in like, we just want the milligrams of fluoride. We just want to know how much fluoride we're getting. So we need to put another equivalent so that we can cancel out liters and gallons. So 3.97 liters is 1 gallon. So we cancel out gallons, we cancel out liters, we're left with milligrams of fluoride, and we are left with 3.97, or basically 4 milligrams of fluoride in a gallon of water. That sounds like a lot. Wait, hang on. Is that going to be toxic? Okay, well, because we're talking about 0.2 to 0.3 per milligram per kilogram of body weight. But down here, we've got like, wait, 5 to 10. Here we have 4. And here's where units are important, because this is 4 milligrams and this is 5 to 10 grams. And a gram is 1,000 times bigger than a milligram. If you do not include units on your number, your answer is wrong. Period. End of sentence. Because the difference between a milligram and a gram is 1,000 times. It's really, really big. So leaving that off leaves your answer meaningless. All right, so we've got 1 gallon of water contains 4 milligrams of fluoride, all right? We're going to be concerned if we're getting more than 0.2 to 0.3 milligrams of fluoride per kilogram of body weight. So now we need to know what a kilogram is. All right, let's do another conversion. This is a good one to just know, to just memorize. A kilogram is about 2.2 pounds. Okay. And this is just useful because kilogram is something that we use a lot, but also because your weight will be smaller in kilograms. So if that's something you like, then yeah, just memorize what your weight is in kilograms. All right, so let's say we have a person who's 150 pounds. How much do they weigh in kilograms? We're going to do another conversion, put kilograms on the top because that's what we want our answer to be in. Pounds cancel out, divide 150 by 2.2, we get 68.18 kilograms. All right, so how much fluoride is toxic for a person that size? Well, let's take the median between these two. So I did 0.25. So we've got a 68.18 kilogram person. We've got 0.25 milligrams of fluoride per kilogram of body weight. The kilograms cancel out, and we are left with 17 milligrams of fluoride. Well, there's 4 milligrams of fluoride in a gallon of water, so you would have to drink 4.25 gallons of water in order to get enough fluoride in your body for it to be toxic if we're talking about regular American tap water. Here's the thing, that much water will kill you. Yes, there is a lethal dose of water. Yes, you can die from drinking too much water. If you drink too much water too fast, and we are talking gallons of water in a fairly short period of time, like in a few hours. If you drink that much water that fast, your blood is going to become too watery, and that is actually going to make your cells swell, including in your brain, and your cells are actually going to start exploding, including your brain, and you will die. Which is why probably the thought of drinking 4 gallons of water made you like kind of nauseous, because that's super gross. And that's because your body would react to that by wanting to throw up, which is what usually happens when people try to drink too much water. So before the fluoride could kill you, because you know what? This is just at the intestinal distress level. Way before the fluoride could cause problems, you're going to die from drinking so much water so fast. Now you may be thinking, hang on though, I drink like a gallon of water a day. Like, aren't I going to get this much in a few days? No, because your kidneys excrete excess fluoride out of your body very, very efficiently. So excess fluoride doesn't build up in your body unless you're taking it in such high rates that your kidneys can't keep up. That's the only way it's going to build up. At this level, this tap water level, your kidneys are like, no problem, I can get rid of any excess we have there. So it won't harm you. All right, let's look at these other things. Excess bone buildup, we need 4 milligrams per liter of water. Kidney damage, 8 parts per million or 8 milligrams per liter. And the only way those happens is if there is already a lot of fluoride in the tap water. There are a couple areas of the United States where the groundwater, because of how the rocks are made, not made, but what's in the rocks. They have a lot of fluoride. So municipal water districts do track how much fluoride is in the water. And there's some other areas of the world, particularly Pakistan, there's an area where the rocks secrete a lot of fluoride, and people have been poisoned by fluoride in their well water. The other way that people get excess fluoride in their body is actually by eating toothpaste, which is why for small children, you use a non-fluoride toothpaste because they're not good at spitting. They tend to swallow the toothpaste and they can actually get too much. And it's why babies, when you make formula, you make it with not tap water. You use distilled water because you don't want the babies to get too much fluoride, because it's pretty easy if you have a very small body to get too much fluoride. But for anybody over about 5 years old, it's pretty hard to get poisoned by fluoride in the water. So there you go. We have defeated a myth. And we made a bunch of equivalencies, which hopefully made sense to you. So we use these prefixes, use their meanings to create conversion factors, and then transformed one number into another to answer some questions. Hopefully that was cool. All right, so what do we learn? We used equivalencies to convert from one unit to another. Always include units. Always include units. Always include units in your answers. Again, if you don't include the units, your answer is wrong. And that's because there's a big difference between a milligram and a gram. All right. Get used to the standard units. You do need to remember what the standard units are and what they are used to measure. So grams for weight, meters for distance, liters for volume. You need to get used to just those few prefixes that I put on this previous slide. Get used to using them. It is helpful to know what centi, milli, and kilo. If you memorize those, that's helpful. You will be given a conversion chart, though. It's helpful to think about the metric system the way you think about money, using the dollar as the standard unit. And if you think of it that way, then if a centimeter is a centimeter relationship to a dollar is the same as a penny, or centimeter to a meter is the same as a penny to a dollar. That's what I'm trying to say. That did not come out well. One more thing, you're going to need this in your homework, in your pre-lab for lab 1. If you see cc, that means cubic centimeter, and that's the same as a milliliter. All right, so I'm going to sign off for that. Sorry, that one was a little bit long. In the next one, which is also going to be a little bit long, we're going to talk about scientific notation.